Okay, so the first thing we're going to do, most of these laws are actually going to be drawn because it's way easier to explain them into drawing. So I'll make the statement and then we'll draw it on the board. The first law is that the path of each planet around the sun is an ellipse with the sun at a focus. Let's draw it out. Don't judge me. Don't judge my drawing. Where's my markers? I have nice markers around. So, I'm going to draw an ellipse, basically an oval. Better. Assume this is a bunny. Assume this is a bunny. We're going to have two axes. Oh, that's a bit rough. Could do better. Ah, that's a great emote. Yeah. 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 There you go. Much better. Much better. Those two. I give up. I give up. Pretend this is symmetrical. Pretend it is beautiful. Let me turn on the light. Ta-da! I don't know if you see better or worse now, to be honest. So an ellipse is a closed curve such as the sum of the distances from any point P on the curve to the two fixed points called the foci. I think I'm saying it right. Foci, F-O-C-I.
Looks like meat's
Back on the menu, boys. Thank you so much for the biddies. We are judging. Am I pronouncing the word right? Foci? F-O-C-I. Does anyone know how to pronounce that word? Is it foci or foci? It is foci. Okay, good, good, good. Thank you. I've only ever read that word. As you see, I haven't taught mechanics. I only do introduction to mechanics. I don't actually do proper mechanics with my. Good to know in future. So what we're going to do is pretend this is symmetrical. Pretend this is very good. What we're going to do is we're going to draw a sun here. So it kind of says that the sun is the focus, and you might be thinking, shouldn't I have drawn in the center? Don't panic. Don't panic. All is good. All is good. You have a sun here. Quite a good drawing of a sun, I think. Quantum physics. No, no, not quantum. Classical mechanics, I promise. Who are you calling foci? So this is F1. And the other foci that we have is F2. It's over here. They probably had no idea that resonance was back in 17th century. This is a hell of a leap. Rava, welcome in, welcome in. I'm glad Drongo dropped you off here. I hope you enjoyed Project Zomboid. Someday I will play Project Zomboid and I will do the physics of Project Zomboid. I have no idea what physics we could do. I know that Science did the physics, the biology of zombies before for Halloween. Or was it Halloween? That still only counts as one. I think it was Halloween. So shout out to Science Streams. He does a lot of science communication, an ambassador of science, mostly around biology. And he was talking about the biology of zombies. So if you are interested in like those kind of little cool things. The day is after Unni, right? Right? What else do I need to fight?
Still only counts as one.
Okay. This is the point. This is our planet. Let's say this is Earth. that's moving around. But it could be any planet. That was the cool thing about it, that it could be any planet at all. Well, not true. I think he did it for any planet that he knew of. I don't think he just did it for Earth. I think he did it for a few planets.
Still only counts as one.
Thank you guys for the follows. You're more than welcome here. That still only counts as one. So it says that the sum of the distances from any point in the P curve to the two fixed points called the foci F1 and F2 remains constant. That is the sum of the distances. So the distance from here, 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 here. Oh, we're getting an interesting shape there, aren't we? I guess what they say the sum of the distances is the distance F1 to P plus F2 to P. Correct me if I'm wrong in interpreting this. Is equal a constant. It is the sum of those two. It's kind of like, you know, when we study kinetic energy and potential energy and they were interchangeable at any given moment? It's the same idea that the sum of these two will always be, keep the notations constant, F1. Same for all points in the curve. What's that spot on the board? I thought it was my screen. That's one of the lights. I actually have 4 lights. I have one turned off. So I have one there, I have one there, I have one there, and I have a purple ring light over here. Exactly, Born Enough. You're absolutely right. So as one gets shorter, the other one gets longer. But I don't know where the sex joke in there. The sex joke in there. But the point is that the sum of them will always be constant at any given moment around these ellipses. Thank you so much, guys, for the follows. Really appreciate it.
Still only counts as one.
How to draw an oval. They do 2 nails and a string. Oh! That makes sense.
Still only counts as one.
I never thought of that.
Still only counts as one.
I've never thought about how to draw an oval, but that makes sense. You put 2 nails down, get a string. So you put a string between these two. You get a marker, I guess, and you like really stretch it out, and you would get a perfect oval. That is so cool. I didn't know that. That was really cool. Yeah, it is down to geometry, Father Dougal. You're absolutely right. That is really, really cool. See, this is what I mean when I say you guys teach as much as I teach you, if I even teach.
Still only counts as
exactly, Taterbots. Every day's a school day. Every day's a school day. Want to make sure there's nothing. There's a comment on saying that a circle is a special case of an ellipse, which the 2 foci coincide and at the center of the circle. So then, if this wasn't a ellipse, you would move these 2 points, I'm assuming, here, and it would be a perfect circle.
Still only counts as one.
Thanks, guys, for the follows. Really appreciate it. I didn't expect the Gimli to be going off so much today. I cannot tell if you're popular today or being followbotted. Actually, we've had so much intense and amazing support in the last few weeks, Father Dougal. It's been amazing.
We don't want any more visitors, well-wishers,
or distant relations. And what about very old friends? Lord, welcome in! 31 months of being a lab rat, and I don't have a simple hut to live in. But if you are a bunny, that's true. If you're a bunny, you have a castle. Welcome in, more. Thank you so much for the 31-month resub. Holy smokes on a cracker. Thank you so much for the support. Welcome in, welcome in. I hope the weather's getting good now. I'm 100% real. Thank you, Harry Polliter, for confirming that I am not buying bot follows here. Okay, so this is the first law. Kepler observed this, and this was true to every planet. This was a really incredible thing. That maybe I should like this, that it's the distance between them that is constant. This was a really, really cool observation that he made. Next thing. Next thing is Kepler's second law, and I'm going to read it out. Kepler's second law states, I have a textbook here to reference, each planet moves so that an imaginary line drawn from the sun to the planet sweeps out equal areas in equal periods of time. What does that mean? Okay, let's draw it out again. It's actually a lot easier when we draw it out. It's usually hard when it's words. Some of us are not wordy people. Let's draw an ellipse again. Don't judge my drawing. Oh, we don't actually need.
That still only counts as one.
That still only counts as one. We have an ellipse again. So within the system, F1 is the sun and F2 is the next largest planet. Or whatever planet you're observing, Villies. Any planet. It just happens that the... Sorry. Oh, F2 isn't the planet. Apologies. F2 is just a focal point. But you're right. P point is the planet. At any part of the circumference of an ellipse? It's not called a circumference. What is it called for an ellipse? Circumference is for a circle, right? Or can you say it for an ellipse? So let me read this part out again, and maybe I can draw it then. Each planet moves so that an imaginary line drawn from the sun to the planet sweeps out equal areas in equal periods of time. So, this path is showing the path of a planet, usually. So let's say we have Earth. Welcome to Earth. You have to do it, you have to do it. And let's say we have the sun. Where's the sun? Hi, Aurelia, welcome in. How you doing? Welcome, welcome. That still only counts as one. How are you keeping? It's just called perimeter. Oh, yeah, perimeter, of course. Why did I forget what the word was? You're absolutely right. It's probably perimeter. Okay, so we have a planet and we have the sun. And as you guys know, the planet rotates. This is a bit exaggerated, but this is how a planet rotates around sun. Example, Earth. As you guys can imagine, the times we are close enough to the, there are times where we're close enough to the sun, and there's times we are away from the sun. And there's also an axis to the Earth, and hence why we have the seasons and the weathers that we have. Now, what it's saying here is that, let's say this is point A and this is point B. The time it takes for the planet to move from point A to point B, the time it takes, say T. And if you draw a the surface, the area, shade in the area from here.
That still only counts as one.
Shade it in.
That still only counts as one.
Guys for the follows, really appreciate it. Welcome in, welcome in. If you heard me, by the way. If you put the same situation here, let's say this is C and D. Might be, I think I exaggerated this oval too much. This is a very exaggerated diagram. Don't judge. But the idea behind it is, let's say it takes the same time. Can you mute the follow sound? I don't usually. It's not like I'm on the front page or anything like that. It's just for a bit of fun. It can be called circumference from the perspective of language, since carry around the shape. Right. Oh, it is very eccentric. That's true. It has a high eccentricity value. You're not wrong, Ramsey. You're not wrong. Time it takes to move. Yeah, making sure I'm rereading again. My mic was struggling to pick you up when you were drawing AB's sun. No, that's fair. That's fair. I did have my back a little bit. But the point is that if it takes the same amount of time to get from C to D here, same amount of time, D, the surface area, the area that it covers is going to be the exact same one over here. Trying to color code it. Area of the green equal to area of the purple. Voila! That is Kepler's second law. There's a direct relationship to the position of the sun and the planet, how long it takes to move across the perimeter, around the perimeter of the ellipse.
That still only counts as one.
With the area that it sweeps as well. That is basically the statement of Kepler's second law, just so I can read it out for you guys again. It is each planet moves so that an imaginary line drawn from the sun, the planet, sweeps in equal areas in equal periods of time. The two T's are not the same length though, right? They're the same length of time, yeah? They should be. That's the direct relationship between them. Perigee, apology. Now I'm getting myself confused. Oh! So AB is moving faster due to gravity. Yeah, you kind of got that instinctually there, correct? There is a stronger swing at that moment.
That still only counts as one.
Guys, for the follows. Yes, in terms of time, yes. Not the swing of the arch, but the sweep of the areas are the same. So the time and the sweep of the. That makes sense? Capital T probably shouldn't be used just because capital T is usually used for period in this case, so it's maybe not the best idea. Why would it take longer to travel from C to D than A to B? And that makes so much sense with its gravity. Well, so if you look at Newton's gravitational law, F, the gravitational constant, r squared. There's an inversely proportional relationship between the force of gravity and r squared. So the idea behind it is you can replace F with ma, which is mg. If you want to get an explanation there for gravity itself here. So what happens is as the planet gets closer to the sun, this r is decreasing, getting smaller. If r squared is getting smaller, the force of gravity has to get bigger. And so, as you can imagine, gravity, mg, its acceleration, it actually speeds up in the process here along this curve line as it gets closer. The further away it gets, r squared becomes larger. And so to keep this chat is... This is the principle of gravity assist. Yep, slingshot method. Oh, my arm. Same idea. Thanks, guys, for the follows. Welcome in, welcome in. Sounds like we can exploit this, and we do. We absolutely do. This whole premise and this whole idea is how orbits work. It's how we get shit to launch. It's why what's that one called? Not Orbiter. There was a launch at the beginning of the year. Brain was the beginning of the year. Blue something. The one that's going to the 4 moons. The Europa Clipper, thank you. So the Europa Clipper was originally only going to take 2 years. However, what ended up happening was that they couldn't use the planned... I'm going to paraphrase. I'm going to get some details wrong. They couldn't use the boosters that they originally wanted to get the Europa Clipper out in there. And originally the plan was going to take 2 years. But they ended up scrapping it. There was issues and they used SpaceX launch instead. And now the whole mission has taken 5-6 years. But they're basing it on gravity assist. What's actually happening is they're trying to get to Jupiter. Hold your horses. This satellite's goal is to get to Jupiter, but they're doing the slingshot method to Venus. They're actually looping around Venus, back around Earth, I think to Mars as well, and then yeeting off to Jupiter. They're doing a really, really long trip, but the idea behind it is they're trying to get that acceleration going. Does this maneuver hurt the planet? I mean, there is this whole discussion that you're technically taking the momentum, rotational momentum, but I think it's so insignificant that we don't hurt the planet. Explaining how mass and gravity affect the bending of space-time and orbits. It's actually, yeah, no, I really like those videos as well. I feel like there's a really good visual representation of space-time. I say very good because some of us, we won't mention names on the stream, don't really know Einstein's general relativity equations very well. Yes, absolutely. Voyager did that as well. Almost all satellites, Cosmo, do it. It's a very, very standard practice. Hey, Lady Spookums, welcome in. 45 stream streak, let's go. Let's go. How do you know when the best time to slingshot it? Oh, you have to simulate it and you have to like predict things and make sure everything is lined up. It's a lot of work. That's why you have whole teams of scientists and engineers working on these projects. Tofu's so smart that she can see in the 10th dimension. Excuse me, I can see strings, Prince Bones, so I'm in the 11th dimension. Clipper's flight trajectory. Thank you so much for the link hacks. Hi, by the way. And thank you guys for the follows. Welcome in, welcome in. By getting something to orbit with enough mass. And you can get things to slow down as well, depending on which rotation, which planet thing, in which direction the planet is rotating, or like it depends on which way you slingshot around things as well. So they could bring back a whale. Oh my god, Brandon, I remember that episode, but I don't remember what you're talking about. I remembered that whale, but I don't remember what they did. Bring it. I don't remember that part. It's the movie. I watched all the movies. No, I didn't. Not the original. I watched all the movies of the original. Why not have actually? I watched all the Next Generation ones. Hi, Bloat. Welcome in. Welcome in. Of course, no problem. Would you go to space given the opportunity? No. No. I'm a scaredy two-face. I am happy on Earth with my bunny doing applied physics and building stuff. I have a fear of a Bunsen burner. I am not going into outer space. Oh, you should watch Deep Space Nine, Alex. It's so good. I really appreciate Deep Space Nine. You could take the bunny with you. Oh my god, imagine if I could take the bunny with me to space. That'd be so funny. So just a quick revision. I'm going to take a little break and make a cup of tea and pee. But before we finish, let me revise really quickly. First law. First law says that the planet that is rotating on an ellipse, there are two focal points, foci, where one is the sun, the other one is the other focal point. The planet is rotating in a given trajectory where the distance from these two and the distance from these two is always a constant. So it doesn't matter where the planet is, the sum of these at any given point will be the same. It's almost like a conservation law. Law number two says that the time it takes for a planet to sweep any part of the perimeter of the ellipse, thank you for reminding me of the word perimeter, from A to B, for example, the time it takes to sweep this, and the three connecting points from those 2 points, whatever time it's sweeping, to the sun, that area is always equal to the area sweep of the same equivalent 2 points of the same time it takes for the sweep to happen. That was very bad English. Any point in any part of your perimeter, you take a sweep of time. A to B, B to D. It could be anywhere. When these two times match up, whatever the times may be, if you draw 3 connecting points, the surface area sweep, if you calculate the area, will always be equal to the other time sweep, as long as the times are equal. That's where I say area is equal to area, and I have a color code. Ooh, my eye hurts. So that is the revision of Kepler's first and second law. When I come back from the break, we will do Kepler's third law, and hopefully, if I have time, what I really want to learn, because for some reason I never cover this, it's a very nice thing, is that we're actually going to cover how Newton proved it via mathematics. So we're going to do some maths. Traumatize you all nice and good. Hi, Logitech. Welcome in, welcome in. Not so much astrophysics as much as classical mechanics. We're just doing Kepler's laws today, and nothing too scary. And hopefully my ellipses weren't too terrible in terms of diagram drawings. And yeah, we'll come back in a couple of moments. I will, what's the word? I'll go make myself a cup of tea. I'll pee. I'll go pet the bunny. She's upstairs probably. I'll say hello to the bunny from you guys. I'll see you in a few moments. To everyone else, do a few jumping jacks. Do a couple of stretches. Reach your toes. And yeah, we'll come back for Kepler's third law. I'm back. Guess who's back? I was going to make tea, but then I was lazy. Then I made iced tea instead. So I have this textbook, and I haven't looked at it. But it is a derivation of the third law in Newton stuff. So we're going to cover that. Hopefully it's understandable. I'm looking forward to it. Welcome back. Welcome back. Happy Sunday, and hi, Sweet Tech. Welcome in. I checked up on Bunny. She is loafing upstairs. She's very tired. Very tired. Sleepy bunny. The Roman Empire, it's back. Hopefully you guys got a stretch, a drink, anything like that. I got myself a iced tea beverage. Good stuff, good stuff. So we have covered, what did we cover? We covered Kepler's first law and second law, and now we're going to cover the third law. I kind of don't want to, maybe I can redraw one of the laws in a smaller corner, just to kind of revise over it, just kind of to have it up, because it's really nice to have all of the 3 laws at the same time. I'm going to make some social media posts about this as well tomorrow. Oh, so tomorrow we're not doing an Irish person for Saint Paddy's. What we'll do is we'll do Kepler's life. So sometimes, because I don't know much about this, I do physics history as well. So because I don't know much about Kepler, I actually would like to, study his life. So we'll just read Britannica or some nice article about him, see what his life was like. Because it seems like he was into astrology. That's interesting. The reason I say that's interesting is like obviously people do people slag for astrology and all of that. But mostly what I'm kind of concerned or like, oh, that's interesting commentary is that was like very anti-religious almost, anti-Catholic. I'm assuming he was Catholic. So very curious of him to kind of propagate that path, if that makes sense. That's kind of where I'm coming from about it. Fun fact, Pythagoras created a cult. He absolutely did. He worshipped the fava bean, and he thought that if you farted, that was inner spirit of you leaving your body. So farting was very, very frowned upon in Pythagoras' cult, and supposedly he sacrificed his life during a fire to save his fava beans. We did study Pythagoras a long time ago. For shits and giggles. It was good. I'm just redrawing the first law really quickly here in the corner just to have it up. We have the sun. We have the sun. He must have really liked. I know. Who the hell sacrifices their life over fava beans of all things? Yeah. Very, very, very. No, it's very not anti-Catholic. All royal courts in the most vehement religious places had royal astrology. Oh, really? I assumed that was very much anti-Catholic. Very interesting. Thanks for the follows. Really appreciate it. Thank you, guys. Had to turn off the follow alerts for a little while. Sorry, my hair is flying because I have a heater on. It's a bit cold in here. Chale. I need to clean this room. Morning, Tofu. Hi, Japer. Welcome in. Pythano gas. Oh, my days. Oh, my days. He was not a Catholic as well. He was banished from Grass because he refused to convert to Catholic. Oh, okay. Listen, we're going to learn all about this tomorrow. Let's go. Tomorrow we'll learn everything about Johannes Kepler. See what all the beef about him is. Okay, so now we're going to cover the last one. They sound fine from a video like I'm watching. Oh, I'm sorry, Hostile. I'm not sure what's going on. Okay, the third law is a mouthful. So let's read the third law carefully. So everyone pick up your ears. Put them up like bunny ears. Let's put on our listening hats because this is a mouthful. Here we go. The ratio of the squares of the periods T of any two planets revolving around the sun is equal to the ratio of the cubes of their mean distance from the sun. Now, mean distance means average distance, okay? But how do you get an average difference, a distance when you're an ellipse? You're not a sphere, or sorry, you're not rotating in a circle. You are rotating. It's an ellipse. The mean distance equals the semi-major axis, i.e. half the distance from the planet's near point N and the far point M. That's the x-axis. Okay. Sorry, there's no diagram here. I have to I might draw this out for myself. The mean distance equals the semi-major axis, half the distance. Oh, okay, so it's saying like the mean distance is taken to be this radius. So not this radius. So sorry. Correct me if I'm wrong, because I don't have a diagram here, but I'm just reading the words. Not this distance, it's this distance. So they're pretending it's a circle with this radius. Am I right in saying that? So let me read that statement. The mean distance equals the semi-major axis, i.e. half the distance from the planet's near point and far point from the sun. Do we reflect its impact on Mars? Is there another asteroid coming in? Welcome in, Ghost. Can anyone confirm or deny what I've stated about the third law of Kepler from reading this? Basically, they take the average of the orbit. Yeah, but which orbit, you know? Yes, my question is the semi-major. What is the semi-major axis? And yes, as it would be the semi-minor axis on the closest points. Excellent. Okay, I was right. Whew. The longer one. Okay, so this one, I say we take it on the chin. Hi, Yuli. Welcome in. Welcome in. It's the shorter one. I don't think so. That's the longer one. Okay, we seem to have contradicting points now in the chat. The minor axis, we said major. We said major, so I guess that makes sense. I have no idea. That's okay. That's okay. I was kind of asking for confirmation. So again, like I said, apologies. I don't have a diagram here. So what it's saying is we have two planets. We have the sun, or we have Earth, let's say. This is Earth. Welcome to Earth. Then we have Mars. They both have orbits, right? Have the sun as well. Yellow marker. Sorry, let me move the mic up here so you guys can hear me a bit better. And we have sun as well. Probably should highlight not drawn to scale. So the Earth orbits around the sun, Mars orbits around the sun, and we can extract a relationship between them. That's kind of the goal here. We can extract a relationship between them. And the relationship is, let's say Earth is 1, or let's do the example. The time it takes for Earth to orbit over the time it takes for Mars to orbit, all to be squared. Get this right? I think this is equal to, what does it say? Is equal to the ratio of the cubes or their mean distance. Is equal to this distance, their major axis, this this radius, say radius of Earth across that major axis over the radius of Mars, but instead of squared, it's cubed. Probably shouldn't be using radius because technically it isn't, you know, a circle, but what do we think? Did I interpret that sentence correctly? I think I did. We can rearrange that equation. We can bring one across the other. I don't know what's happening here, but I'm invested. 3 celestial bodies, almost like a 3-body problem. Have you watched the TV show or the movie? How did he figure this out by observation alone? Absolutely incredible. I think... So this was 1600. What did we discover in the sky? We need to confirm this. What did he use historically? What planets did he use? Mars? Venus? Mercury? Definitely not. Oh, telescope, of course. I meant what planets did he use? What planets did he use in this case? Can approximate the semi-major using the planet's mean orbital radius. Okay, cool. I think Mars. Moon? I don't think we could do it for the moon. Yeah, no, it has to be orbiting the same body. Otherwise, the ratio wouldn't be identical. Unless there was 2 moons to study. Hey, Paki, welcome in. Yeah, we'll be doing Half-Life later today. Father Dougal says Mars, Jupiter, Saturn, perhaps. Jupiter, maybe? Okay, let's actually look this up. Let's Google this. Let's pop up on my Google and let's look. What planets did Johannes Kepler observe for his laws? Which planets did he observe? Oh, there's a lot. Oh, come on. No, this article doesn't say. Okay, here we go. Velis has something in here. Johannes Kepler primarily focused his astronomical studies on Mars, using Tycho Brahe's data to develop his laws of planetary motion, was also applied to other planets like Mercury, Venus, Earth, Jupiter, and Saturn. So that part of like, that also applied implies that he didn't do that though. Am I right in saying that? Wikipedia says he tried many combinations until he discovered approximately the square of the periodic times to each. Although he gives the data of his epiphany, he does not give any details about how he arrived. Oh, dun 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 dun! Although he gives the date of his epiphany, he does not give any details about how he arrived to this conclusion. Spice. That is spice. Could use, yeah, I'm assuming it was Earth and Mars. I'm assuming, but how do you confirm it? That was just the observation for 2 planets. You need, I would say, at least another one. While Mars was the primary focus, Kepler's were later generalized. Yeah, so that's different again. It's the same statement, at least I think. It's implying that he didn't do that for all of them. Am I? So Kepler's work strongly supported the Copernican model of the solar system. That's right. So it seems like he only worked with Mars and then kind of whiffed it. Maybe that's what actually happened. Kepler predicted and did everything based on Mars, and there was no way to truly prove it until he could apply to other planets. Past his life, then they were able to apply to his planets. So it's all after his death. Oh, what's that word? Not hindsight. What's the word when something happens after someone's death? There's an English word for it. Posthumous. Thank you. I think I said it. It's not posthumous, is it? How do you say it? I thought it was posthumous. I've heard the word. Okay. Posthumous. Posthumous? Is that actually how you say that word? Posthumous indeed. I've been saying that word wrong all my life. Posthumous? Posthumous. Okay. Maybe I'm getting closer. First syllable rhymes with frost. Posthumous. Posthumous! Did I get it right? I think I've heard that word before. No, go back. Posthumous? Yes, okay, there we go. Woohoo! I'm learning English. Life is tough when you didn't have friends growing up. Oh, Lord. Posthumous would be definitely fine in getting your joke after you're done. Yeah, I've been saying that word wrong all my life. I don't know why. I think what's really funny is when you've heard a word, you've read a word, and it never clicked in your brain. Those two things, you know? I don't know if anyone else has had that problem before. that those two words did not click at all. And like, you have a definition of both of the words as well. And obviously they're similar, but you know, there's a lot of similarities with some words. And you legit thought they were two separate things for the longest time. I feel the same when I hear American and English for things like privacy. Yes, it's privacy in American, I think. Do we need one of these, but for English? You're probably not wrong, Shadow. Do you want to learn a new Irish word? Is there any word off Squelga you want to learn? We have a few Irish people. Noz may be still around. Father Dougal is here. I'm sure he knows plenty of Irish to help us out if need be. Spot of tea. Exactly. Okay. Maybe I shouldn't have used or. Now, there's the thing that I want to look at. To derive Kepler's third law for a special case of circular orbit specifically, in which mean the distance s is basically going to be the radius r, which is kind of what we did there anyway. And it all starts from Newton's second law. Do you guys remember what second law is? Thanks so much for the follows, Falafel, Budman, Mundane. Thank you all of you guys for the follow. Sorry, I've the sound alerts turned off a little. It's a little bit chaotic today. F is equal to MA. Excellent. We're on top of it. What is ellipse in Irish, I guess? Okay, let's look it up. What is ellipse oscuelga? Ellipse oscuelga. Ellipse. Ellipse. Not as exciting as I thought it would be. For every force. My force equals your mass times acceleration. Rate of change of momentum. That's another one, yeah? But we'll use mass times acceleration. There's an equal and opposite reaction. We're speeding ahead, painter. That's third law. But you're absolutely right. That is the third law. First law is all about inertia. The second law is force is equal to mass times acceleration. And the third law is every action has an equal and opposite reaction, which is how we get rockets into space. Now, how do we start? Let's look at this derivation. So I am referencing a textbook in case anyone wants to know. Giancoli is the textbook. It's a first year physics textbook. But I used to shit on this book before, and then I realized there's actually such lovely little gems in this textbook. Like a geostationary orbit, all those good stuff in there. I was like, this is fun physics. Like, this is the physics that I would love to teach. So I really, really do appreciate it. And yeah, it has the third law derived via Newton's laws. So in this case, we're going to use F as the universal law of gravitation for the force between the sun and the planet M. Okay. Let's do it on the board. So maybe I make some. What about Mercury? Oh, now we're gonna see. Start off this. Man, that whiteboard flipped. Oh my god. I didn't have a whiteboard before, and now that I have one, I can never go back. It's so fantastic having one in the house. I mean, I get it that I'm a teacher, and so it's important for me, but even like most teachers don't have whiteboards. We'll see. Now, we're gonna start off standing for mass, A standing for acceleration. Goal started successfully. What goal did I start successfully? Huh? Which? And so what we're going to put in here, what is M1 going to stand for? And a planet of mass 1. Okay. So we're going to have a planet with mass 1. And we're going to have the sun with mass of a sun. Yeah, we're just going to replace this with Newton's gravitational law. That's G equal to M, mass of the sun, times mass of the planet, all over, I'm guessing R squared. I know that it's the semi-major axis, but we're going to assume circular motion. We're going to do approximation. So we're going to do... It's just the distance again. Just notice the Lego Artemis. Yeah, it's in the corner. Right there. Cat is blocking half of it. But yeah, it has even like inside it, the satellite fits in too. But I take it out, and like it's mechanical. It can look. So it closes. The solar panels close, and it fits inside the rocket closed, and then they open up. Voila. Absolutely right. The inverse square law is the backbone. It's in everything and anything that we see. And basically what we're going to do is we're also going to replace what the acceleration is. And the acceleration in this case, we have another relationship for it. We are going to use v squared over r. Oh! Over r. Apologies. No squared there. There's no squared. Oh, shoot. You don't see it. Thank you. Apologies. As a noob. So, I'm basically replacing F with Newton's gravitational law, and over here, what I've done is I've replaced A with another equation, v squared over r. I've done centripetal forces before. Like I've done a bit of circular motion with you guys in the past, so take it with a grain of salt if you haven't covered it. It's okay, but if you do remember, we can remember. Just to be wary about that. Now, the book says, here M1 is the mass of a particular planet. Okay, I thought we knew that. R is the distance from the sun. Yep. V is the speed in orbit. Okay. MS is the mass of the sun. Oh, okay. This textbook is really holding your hand. If anyone studies physics and has physics textbooks, usually it's like, here's an equation. Bitch, wish you luck deriving where it comes from. The period T1 of the planet. Okay. Oh, right. Okay. So a small little sidetrack. Kind of remember. For security and squared. A very important thing to talk about is the period. The time it takes for a planet to orbit around it. And there is a relationship. So we have time. We have the velocity. And we just need to know what the distance is. And if we're assuming a circular orbit, what is the perimeter of a circle? Do you guys remember? Sorry, itchy nose. Itchy nose. 2 pi r. Let's go, Kip. 2 pi r. Two pi r is the circumference of a circle. T is the time it takes to complete that circle. That's just distance over time. Distance over time is speed. Kilometers per hour, miles per hour, whatever unit you guys use in your respective countries, that's just speed. So we have an expression for speed. Second, but the security works too. Father Dougal, 2 pi. Oh, pi r squared. That's that was area. It's so funny to think that, you know, like your brain works immediately in that area, in that thing. But sorry, I'm getting a bit of a drink here. A little bit of like a guide in your brain. This is not true for all, for things like cones and cylinders, but whatever you're squaring, the dimension, whatever you're squaring R with, is the dimension you're working with. So if R exists on its own, we're working in 2 dimensions. Okay, I said that wrong. If R is on its own, we're working with lines, okay, i.e. perimeters. If we're working with R squared, that means we are working with area, i.e. in 2 dimensions. And then finally, if it's R cubed, we are working in volume, in 3 dimensions. Now, why that doesn't work for... sorry, I shone a light on everyone. Why that doesn't work for other things is, for example, a cylinder is pi r squared h. I had to remember the formula off by heart there. But the way I remember it is it's an area. It's the area of a circle, right? A disc, multiplied by all the discs that you need to stack up until you get the height, i.e. that's why you're multiplying by height. So some shapes, like for example a cylinder, it doesn't work. But usually when we're talking about perimeter, area of a circle, volume of a circle, the squared thing works. Maybe. How much is that in bananas? I do always like to slag the imperial system a little bit, especially in the States, because it's always so funny that usually they refer to something and they'll say something in imperial units, and then in brackets, instead of putting in brackets the SI unit or the metric system or anything, they say that's about 10 chihuahuas, that's about 4 guinea pigs, that's about half a football field. Use any unit except the SI. Anyways, that's my little joke, my little beef. Anywho, we now have an expression for the velocity. What we can do is sub in that expression of velocity in here. So let's rewrite that equation. Times mass of the sun times mass of our planet all over r squared is equal to m1. Now we have how should we write it then? Should I square it out immediately? I think I'll square it out. We're just going to square it out immediately. And the 4's get rid of 4 then. Yeah, it will. So just what happened there is it's V1. V1 is equal to 2 pi r t over t. But we need to square it. Squared. 2 squared is 4. Pi squared is pi squared. R squared is r squared, but it's only 1 r. It's only 1 r because there was an r below. So 2 of the r's cancelled all over t, again, to be squared. But I forgot a lot of squares there. Hi, Move, welcome in. But anyways, going through it slowly is a good way. Maybe you shouldn't skip the step. Don't skip the step maybe next time, like Tofu did. Make sure you have the maths right, because I made a mistake there that way. The SI unit of 1 time the Earth goes around. I'll take it. Listen, boom. Sometimes beggars can't be choosers. Now, what we can do is, it says here that you can rearrange the equation to find t1 squared over r cubed. Okay, but then the masses will cancel, right? Well, look, I'll do the maths. Let's see if I match up with the book. First of all, the 2 masses cancel. Agreed? Can't we just relate the period to the semi-major axis? But we're trying to do this without using Kepler's laws. So that's one of Kepler's laws, fanatic. We can't skip ahead. Oh, is that sunshine outside? It is. Beautiful sun outside. Look at that. Look at this bright sun in Ireland. This is Ireland. Can you imagine? Can you imagine? Let's see if the camera actually fixes. My eyes. I should have given a warning that I did this, to be honest. Apologies. Let's see if... Will the exposure control it? What do you think? Natural light? Yay? Nay? Kind of does glare a little bit. But it actually looks better. The camera does look better in natural light. Mead over here. Yeah, so there might be a bit of bright light occasionally, but I think the board actually looks pretty good. Pretty nice, pretty nice. Okay. Sorry, let's keep the maths going. So I want to put, I think the t squared, the r squared over, so there's one r squared here. That will be r cubed. What do we have left? Then we have 4 pi all over gravitational constant. Done. Did I do that right? Did I do any mistake there? Let me see if I... Okay, it's the same as the textbook. Excellent, excellent. Hey, Jay's not here to ask permission. Good try, Alex. Oh, I can see the cam spectrum better now. Hi, Ayat. Hello, Ella Dola. Welcome in, welcome in. Thank you guys so much for the follows. You guys are more than welcome here. We're just in the middle of deriving Kepler's third law, but using Newton stuff. Now, I should probably keep track of the fact that this is the radius of the first planet. What we can do is that we can repeat this whole process, but for a second planet. But we're just going to get the same equation, right? We're just to explain, we're just going to get over cubed equal to 4 pi squared m dying out. We're just going to get the same thing. This other planet. I assume that's it, actually, yeah. So, if we repeat the steps again for any other planet in orbit around Earth, what you're going to notice is the 4 pi squared over GMS is actually equal on both sides. Same thing. So we can equate those two things. Our final equation, or our final expression, that 1 squared for R1 is equal to T squared for R. There's a direct relationship with the radius of any planet in our solar system with its period, the time it takes to orbit around the sun. There's a direct relationship between them. This is Kepler's third law. But what, just rearrange it ever so slightly and you get the same thing. And so what's really unique about this is that Newton was able to do this 100, maybe I'm wrong in saying 100 years later, maybe almost 100 years later. So after Kepler did this observation, or as we read according to Wikipedia, that it turns out that he wrote it but never said how he knew it. Very, very sus there. Maybe we'll learn something tomorrow. But what we learned here is that you can derive Newton's laws, or you can derive the same Kepler's laws using Newton's laws. This was a huge validation for Newton's work as well. Oh, not radius. Sorry, when I say radius of the planet, I mean radius of the planet's orbit. When I say radius of planet, I mean radius of planet's orbit. Sus. Just an FYI. That's really cool. I actually never studied this. It's so cool to see this. I don't know. I really like go back to basic physics. There are so many things I skipped over and never thought about. It's really cool to me. Hi, Gov. Welcome in. Or is planet orbit? Exactly, exactly. Thanks a million for the follows, guys. You're more than welcome here. A bit of sunlight happening here in Ireland, so apologies for the bright lights, but look, listen, it's beautiful weather here in Ireland today, so we have to take it while we have it. Oh, look at this vitamin D. Although the UV light doesn't penetrate through. So I'm not getting much of it. Kepler kept it to himself. Listen, maybe Kepler just wasn't a good note taker. I was terrible during my PhD in taking notes, which was very bad practice. But I was not very good at taking notes. So listen. You know? You never know. You never know. We want vitamin D in the mines too. You'll get your vitamin D if the bunny overlord gives you permission to. For anyone coming in, we have a bunny. That's why I have a pillow on the... If you're wondering, why does she have a pillow on the ground? Sometimes the bunny runs in here and thumps us. She does come in here and thumps us a little bit. But yeah, she's sleeping usually during this time. So the only reason I think she came in yesterday to thump, it was still morning when I streamed. And she's kind of hyper in the morning. She's very active in the morning and very active in the evening. During the day, she sleeps. So I think she's sleeping still. You still have to open the window then to get the vitamin D. Yeah, and I don't have direct sunlight. I'm only getting scattered light as well. I don't know. Many scientists back in the day didn't have spouses. They didn't have wives. Some of the greatest physicists of all time did not have spouses. And so they achieved some of their greatest physics. So the moral of the story is, if you have a wife or a husband or, you know, a significant other, it ruins your brain. That being said, okay, I was going to make a comment about Schrodinger, but honestly, Schrodinger is a terrible example because it turns out that he kept going for younger ladies to the point of it being illegal. Marie Curie did okay. Yes, Alex, but also she got an independent Nobel Prize after Pierre died. Silkern, thank you so much for the 100 bits. By the way, one rotation of Earth is 361 degrees to the face sun again, since 1 degree in its orbit. Oh, is that the whole time thing? I didn't think about it in that way. Thank you so much for the 100 bits. You gave so many bits already today. Half-Blood, thank you so much for the Prime. Really appreciate it. Gurv Mila. My precious. Some of the greatest spouses were better scientists as such than their spouse. Oh, that's true, roast beef. There was some rumors. Yep, that is true. Pete, thank you so much. Oh, lads, really appreciate the subs. Thank you so much. Very, very kind of you. Thank you. Always take care of yourselves and your family. I appreciate it, but not to say no. Obviously, I really appreciate the financial support. I can grow my stream. I can buy stuff then. But just an FYI that I am full-time lecturer and researcher, so I'm all good in life. But any extra money and bits is given to feeding that bunny. Where is she? That bunny on my chair, on my stairs at the moment. That's true. I literally heard about that, Jack. Yesterday. Was it yesterday or the day before? Darwin did marry his cousin. I think what's really cute though, what's really cute about that, if you want to see it in a cute way, is that he made a pros and cons list before marrying. Pros included things like company and lady chatter. Pleasant lady chatter. Cons was anxiety, responsibility, and less money for books. The data showing divorce around 50% says otherwise. Hey, thanks a million for your Prime. Welcome in, welcome in. Who was the scientist that met his current wife at the Congress for the Prize Award? Don't know much about that. Oh, look at that. 2 hours. Yes, I completed my physics lesson in 2 hours. Chat tried to derail me. And I didn't let you, chat. We actually did the whole lesson. We did all of 3 Kepler's laws. I almost feel like I'm showing you the middle finger. And number 4, we also derived the third law using Newton's laws. I think you can do it to Kepler's first law and second law as well, but it might need some calculus. Am I right in saying that? Does anyone know? Hi, poopy head. Ross also made a list and Rachel... Oh, yeah, that's true. I forgot about the list that Ross made. I feel like Darren's list was not bad, though. It was nowhere as bad as what Ross did, to be fair. Gosh, thank you so much for your sub. Holy smokes. A mine! All aboard the scam train. Choo-choo. Chat, we have some derailing practice to do. That's true, Napsmore, it is. I do tend to avoid calculus when I teach physics here on Twitch because like basic algebra, I think a lot of people do cover it. And to a certain extent, if you didn't follow my rearranging equations here above, you can kind of almost say, trust me, bro, you know? But the reason I've avoided anything calculus-based is that I do want to make this accessible to anyone and everyone coming in. So obviously a lot of physics is maths and it's unavoidable, but I hope to teach physics using very, very basic maths. But maybe it is a thought for food that I could do introduction to calculus someday. That'd be a nice video maybe for anyone who does want to learn a little bit about it. Just very classical differentiation and integration, especially with slopes and things like that. Sorry, I just missed the lesson. No worries, no worries. I got to logarithms. It's the integrals that killed me. Thank you so much, Dosh, for your sub. Really appreciate it. And Pete and Halfblood, thank you guys for your prime. Really, really appreciate the support. Thank you all guys for the follows as well. I'm so sorry. I turned off the follower alerts. Not sure what happened, but there's been a lot of traction and viewership lately, which is obviously great, but I haven't studied calculus in ages since I was in school. Sign me up. Yeah, and the calculus that I do is very, very specific as well. Like it's a huge, broad subject, but you know, over the years I do a very specific niche in mechanics and an electromag, and like I only do a very, very, you know, specific corner of it. The intuitive is hard, isn't it, Spike? It's really hard. I would love to teach it intuitively instead, if I could. But it's tough. 100 follows today alone. Did I actually? Boom. I hate calculus. It's okay, hydrophobic. I get it. Great username, by the way. I understand. I grew up in a time where you either got it or... Yeah, no, I understand that, Galactus Surfer. Maybe not maths. I can't speak for maths because I'm not a maths teacher. But you know, I teach first year physics to a lot of students who are not going to do physics anymore. They have to do first year physics if you're a pharmaceutical scientist, biologist, chemist. If you're any scientist out there, you do need to study first year physics. And so I get that I obviously want to inspire kids and make it interesting for them, and I want to make sure that, you know, they have a good time with it. But what I'm trying to do now, or my goal, isn't to convert people into physicists, but rather to ensure that they have a positive experience with physics. Most students will take first year physics and never do physics again, and a lot of students have a bad experience, very similar to maths. Precious. Thank you so much for your prime, Void. Holy shit. So many primes in a row. Thank you. Really appreciate the support. Thank you. So many people have a bad experience with physics, similar to maths. And so now my goal, or like my mindset with teaching my students, is that I just want them to have a positive experience with it. I hope. Void, thank you again so much for your prime. Really appreciate it. Thank you. Hi, Tide. Welcome in. Decided by the derivative of pi equals cute physics teacher on Twitch. The third law tells me when I know the T and the R of the Earth and the T of another planet, I can calculate it or it has. Exactly. Or the opposite, Zilkarin. If you know T and R of the Earth in our solar system and you know the R of any other planet, you can calculate the T or vice versa. So you're absolutely right about that. You're absolutely right. Do you rock climb? I used to actually. Not rock climb. I used to do, what's the word? Bouldering. Not rock climbing. What part of your physics class? Optics, mechanics? As in what subjects do I teach physics? Is that what you asked? It's also more fun that there's no pressure for learning physics. Fair. Fair.
Precious.
Hi, Go-san. Thanks. There's so many primes. I think this is literally a prime hype train. Thank you so much for the hype train. Really, really appreciate it. And thank you so much for the follows. You guys are more than welcome here. Thank you. Thank you. But you're absolutely right about the pressures of learning. When I studied physics in my bachelor's and my master's degree, I did so many subjects. I almost didn't care for them. It's after becoming a physicist and then being a lecturer and being a teacher that I just freaking fall in love with physics. Oh, I love physics now. What subjects do you teach? I teach general physics, which means I do like introduction to first years. I also teach logic gates, semiconductor, introduction to semiconductor, logic gate thing, and the module name is on, and AC/DC. There is another subject that is up for grabs, and I don't know if I want to take it because it's not very physicsy, but also I don't know. It's a useful module, but you'll see. At the moment, there is a subject up for grabs that I really want to do, which is advanced mechanics, and that's the one I am going to see if I can pull up on, because, oh, give me Lagrange. I want to do Lagrange now. I used to hate it when I was younger. Now I want to do Lagrange. Galactic Surfer, thank you so much for the resub of your Prime. Thank you for trying to make comfortable, to make it comfortable to learn physics. There are a lot of shy learners out there. Thank you so much for your Prime. I really appreciate the support and the kind words. Thank you. Lagrangians? So Lagrange is used in a lot of really cool... You've heard of the word, actually. Well, I'm assuming some of you guys have heard of the word. Hi, thank you so much for the sub. Holy smokes and a cracker.
Call it a mine.
Oh, mine! Not Hubble telescope, help me. James Webb. When James Webb went into the solar system, into orbit, do you guys remember that it was at a Lagrange point and they were trying to determine at which point it would be safe? You remember that? Maybe some of you heard it in the news. Double Tribble has heard it. Excellent. Unique Beast. Excellent. Yeah. So Lagrange developed a whole kind of mathematics, mechanics-based mathematics around this, which is really, really important. And yeah, you guys have heard. Yeah, exactly. Is a L2? Someone says L4. I think it was L2 though. I could be wrong. It's been years since I last heard it. If anyone could do a quick Google to confirm or deny the rumors I'm spreading. Exactly, Grim. You're absolutely right. Hi, thank you so much for the sub. Really appreciate it. Thank you. Thanks, guys, for the follows. Granted, it's probably jammed up to the progress. Oh. Anyways, it was so fun teaching you physics. There was a lot of follows today, incredible amount of follows. Thank you so much for Bloody Drongor and Slow for the raid earlier as well. If you guys are interested, I usually stream on the weekends at this time. Special thing happening is that tomorrow I'll be streaming. It's a Monday, and you're like, why is she streaming on a Monday? Shouldn't she be lecturing? It's a bank holiday in Ireland. It is St. Patrick's Day, so we're off, and I will be using that time to stream and play video games. Hi, Amelia. Welcome in. Orbit L2 per internet. Thank you, Mediocre Bard, for the confirmation. Appreciate it. appreciated. So tomorrow we're not actually going to do like mathematics physics. Instead, tomorrow the subject I'll be choosing is, I want to actually look into the history of Johannes Kepler. I'm going to look in like what he did, how he lived, because we learned so many spicy stuff. You know, we did the history of Boyle, we did the history of Kelvin, we do the history of some famous scientists sometimes, like Pauli, Fermi, and you find out so much spice about them. So yeah, we'd love to look into Johannes Kepler, any documentation that he has about his life. It'll be really interesting. So that'll be our physics topic tomorrow. And then we'll be continuing playing Half-Life like I will be doing right now. I just need a pee. I'm bursting to pee. And an O'Neill habitat. Nice. Drama, exactly. We find so much drama between physicists. There's like, oh my days. The amount of drama we find. Yeah. Chef's kiss amount of. Okay, I'm gonna go pee. When I come back, we are playing the original Half-Life series. Usually I do physics topics around the video game I'm playing. So on Friday, I launched a rocket into space. That's where Kepler came from. That's my logic. Oh, I think I need to change one of my tags. I don't think one of my tags is truthful. Dragon Age. There's a YouTube channel called Parallax Nick that has some great videos on Kepler and other physicists. Oh, cool. While we're sharing foodie, I'll check it out. And there's another one is History with the lady's name. And she does the history of loads of people. And there's loads of electricity stuff. Coulomb and Volta and Galvani, all those people. Oh, history with
Looks like meat's
someone.
back on the menu, boys.
I don't think that's an easy thing to explain, Zilker. Thank you so much for the 100 bits. I'm so sorry I can't explain that. We actually have to go into really difficult mechanics to explain that. I don't know if I can paraphrase enough. Yeah. I'm so sorry, Zilgren. And by the way, congratulations on your choo-choo train. Alright, I'm gonna go back. I'll see you in a couple of moments. I'm gonna pee. I'm gonna grab a cup of tea. Will I grab alcohol? Is it alcohol time yet? It's 4 o'clock. Maybe I should hold off the alcohol. Sugar Glider, welcome in. It is a bank holiday. And I'll fix the lighting.